Hello everyone. A voltage converter from 12 to 220 volts is a very useful thing. Today I want to assemble one of the simplest converters, which consists of only 12 parts. You can download the schematic diagram of such a converter in the Telegram group. The link to this group will be in the description under the video. In order to make accurate measurements of the parameters of such a converter, as well as to see the shape of the output signal, I will use a modern digital multimeter with an oscilloscope function from ToolTop. A wonderful thing for an electronics workshop. In the description below this video, I will leave a link by clicking on which you can learn more about the multimeter and also, if desired, purchase it. On the back of the box are the technical specifications of this device. Measurement of constant voltage up to 1000 volts, alternating voltage up to 750 volts, the current strength is up to 10 amperes, resistance up to 40 megohms, capacity up to 10 millifarads, frequency measurement up to 5 megahertz. In addition, there are several additional functions in this device, for example an oscilloscope, which makes this device especially useful, as well as relative value measurement, peak value measurement and the function of switching to sleep mode after 15 minutes of inactivity. Inside the box is a user manual, a multimeter in a case and test leads. Instructions in English with a detailed description of all operating modes. The probes are comfortable with a soft and, quite possibly, silicone wire. They are designed for a maximum voltage of 1000 volts and a current of up to 10 amperes. And here is the multimeter itself. Rather strict, but quite a nice design. This multimeter has a large color screen. There are 6 buttons under the screen to enable and disable additional functions. And this is the switch of the main modes. And at the bottom of the multimeter there are 4 connectors for connecting probes. It's common. This is the main one where almost all measurements are made. Milliamps and millifarads are measured in this connector. And this connector is for measuring current up to 10 amperes. The probes are connected and now I will check some operating modes of this multimeter. The first mode is the measurement of a small DC voltage, that is, millivolts. The next mode is the measurement of constant voltage. 1608 volts. Using these buttons, you can enable and disable additional features of this multimeter. For example, the F1 button enables relative measurement mode. How does it work? To begin with, I will measure the voltage on the charger. And it is 5.8 volts. Now I will press the F1 button and measure the voltage of this battery, which is within 1.6 volts. The difference between the charger voltage and this battery is 3.48 volts. The F2 button turns on the peak value measurement mode. I measure the battery voltage again. 1.6 volts. Now the maximum value has been preserved and it is 1.6 volts. And now I'm measuring the voltage on the charger. 5.8 volts. Now this new peak value has been preserved. The cell button switches several modes. Frequency measurement, duty cycle and DC voltage measurement again. The F4 button enables automatic measurement mode. The S button saves the measurement value on the screen. And with the R button, you can turn on the oscilloscope. Here, using the upper buttons, you can also make some settings, for example, select a time slice. You can select the amplitude or trigger. The next measurement mode is alternating voltage. The voltage in the network is 246 volts and the multimeter reports with an audible signal that we are dealing with a high voltage. Let's look at the signal form of the household network. As expected, there is a pure sine wave in the household network. It is also worth noting that this multimeter does an excellent job with its oscilloscope function. The following measurement mode includes several sub-items. You can measure resistance, capacitance, test diodes and an electrical circuit. Using the cell button, that is F3, you can choose what exactly you need to measure. The next measurement mode is millifarads, then the milliamps. And another mode is the measurement of high currents up to 10 amperes. Well, I can say without exaggeration that a multimeter from ToolTop is a very high quality and reliable device with many functions and capabilities. For me personally, the oscilloscope function is especially useful here. Well, now we can proceed to the assembly of the voltage converter, which I will then check with this multimeter. The converter circuit is very simple. It consists of a multivibrator that controls two powerful field effect transistors, and a transformer is already connected to them, alternately opening and closing transistors, so to speak, shake the transformer, and a voltage of 220 volts appears at its output. Any suitable transformer can be used. Its primary winding is designed for 220 volts, and the secondary for 24 volts with output from the midpoint, that is, 2/2 of 12 volts are obtained. In this scheme, the transformer is connected to the transistors by a secondary winding. You can download the schematic diagram of the converter and the Telegram group. I soldered the transistor, now it's the turn of the resistors. It remains to solder the capacitors and a couple of resistors. I soldered the necessary wires and fixed them with a shrink tube. The transformer that I will use in this converter is, frankly, weak. It has a small power and a rather thin wire in the secondary winding. Because of this, it will not be possible to check the capabilities of the converter to the maximum, but you can definitely make sure that it is working properly. Everything is ready to test this simple converter. Now I will connect the probes to the transformer and then I will supply voltage from the battery. The output voltage of this converter is 260 volts. Now let's see what the current frequency is. The frequency is 73 Hz. As you can see, the voltage and current frequency of this converter are slightly increased. To fix this, I will now change the frequency of the master multivibrator. Capacitors with a capacity of 1 microfarad are installed here. I will add one more capacitor in parallel to each capacitor so that the capacity on each side of the multivibrator is about 1.5 microfarads. Then the characteristics of the converter will be normal. I soldered the capacitors to 0.47 microfarads and now there are about 1.5 microfarads on each side of the multivibrator. Let's see what characteristics this converter will have now. The voltage is 254 volts. Slightly raised, but better than it was. Now let's check the frequency. And the frequency is almost 50 Hz, what was required. Now let's look at the waveform at the output of this converter. The output waveform is not a sine wave. It looks more like rectangular pulses, but of course, one should not expect anything more from such a simple converter. But, nevertheless, it is quite a working converter. Now I will connect the load to it, and we will be able to verify this. First I will connect the LED lamp. As you can see, the lamp works perfectly and shines at full brightness. Now, instead of an LED lamp, I will try to turn on an ordinary incandescent lamp. This is a 60-watt incandescent lamp. It glows at about half the intensity or even a little less. If the transformer was more powerful, then the result would be much better. Well, in this configuration, the result is appropriate. And another test subject is a 300-watt mixer. Let's see if it can work from such a converter. The mixer is spinning, but not too fast and, of course, it is unlikely to beat something with it. It remains only to find out what current this converter consumes. First, I will measure the current strength when there's an LED lamp in the load of the converter. As you can see, the current strength is approximately 1.38 amperes. If there is an ordinary incandescent lamp in the load, then the current consumption increases significantly and is approximately 3.8 amperes. This concludes this video. If you liked it, then click the subscribe button so as not to miss the new video on my channel, which will appear very soon. I thank you for watching and see you soon.